Hello students, in this video I am going to continue with the problems on convolution sum where we left in the last video. This problem was given to try on yourself. Given a signal x of n is equal to 2 delta n minus delta n minus 1, and h of n is similar to the previous problem which is varying from -1 to +3, having a samples 1, 3, 2, -1 and +1. Now this problem we have to plot x of n first as in the previous problem, and h of n is the same. For this we have to perform convolution using graphical method. Now I have already plotted this x of n, and I will just explain the steps how we got the x of n here. So coming to this first one, you observe this, we want to perform two operations, 2 delta n and minus delta n minus 1. So to get x of n we need this and these two signals. Now first I will plot the 2 delta n. You can see this here, 2 into delta n. Delta n is a impulse function where it is present only at the origin. Since we have an amplitude 2, so 2 is the amplitude at the origin, so 2 delta n. Now to plot delta n minus 1, so first I have plotted minus delta n minus 1 is the signal that is required. First I have plotted delta n minus 1, so it is time shifted towards right one time with an amplitude 1. Now to get minus delta n minus 1, so we have to multiply the entire signal with the minus. So the amplitude of +1 will become -1. So this is the signal minus delta n minus 1. Now this signal I have written here for convenience to perform addition operation. So we are performing addition of this. So 2 delta n plus minus of delta n minus 1. Now when you perform this addition operation, at origin we have amplitude 2, we have sample with amplitude 2, and at 1 we have a sample with amplitude -1. So both of them are added to get 2 delta n minus delta n minus 1. So this is the end signal, which is nothing but our x of n. Now this x of n is convolved with our impulse response h of n. So what is the signal h of n? 1, 3, 2, -1, +1. So starting from -1 to +3, I guess. Yes, +3. These are the two signals for which we have to perform convolution. Since going through the signals, we can see x of n has less number of samples. So I will prefer this one, y of n is equal to x of n convolved with h of n, keeping x of n constant and h of n as a time shifted one. Okay, so you can just elaborate this. Summation k is equal to -infinity to +infinity x of k h of n minus k. So this is just for clarification which signal you are keeping as a constant one and which one will be the time shifted one. Now when you perform the convolution operation using graphical method, I am not going to go for all the steps. I will give you the end result y of n. You can apply the previous graphical method and verify whether you are getting the same samples or not. Okay, and you can verify with the procedure that I have explained in the last video whether the answer you are getting is right or wrong. So the signal varies from -1 to +4, 1, 2, 3, 4. Okay, so I'll just give you the samples, final answer. At -1 you will get 2, and at origin you will get 5, and at index 1 the amplitude will be 1 here, and at 2 we'll get a signal with amplitude -4, and at 3 you'll get a sample with amplitude 3, and at 4 you'll get a signal with amplitude -1. So this is the end signal y of n. So you can verify with your answers whether it is right or wrong. So this is the second problem solution for you. Now we'll move on to the next kind of problem, and you can observe this, both the signals here. So they are deterministic signal. That means we have very less samples here. You can see the starting index and end index, and which will be a fewer samples. So some, in the next case I will taking a different kind of signal. So here is the problem for you. We have a LTI system which is characterized by an impulse response. H of n is equal to 3 by 4 to the power of n, h of n, and so they have asked you, I think it's not h of n, I guess it is u of n. Okay, so this one is u of n, So find the step response of the system and also evaluate the output of the system at n is equal to plus or minus 5. So this take a few different approach to solve the problem here. So one thing is h of n is given, and they have not given x of n, but they have asked you to find the step response. Now what is step response? So to get that clarified, so observe this, we have a system. Consider this box as a system with system operator h. Okay. Now to get a step response as an output, your input x of n should be a unit step function. That is, your x of n should be a unit step function, that is u of n. So if you apply unit step function as an input to a system, then only you will get an output as a step response. Okay. So that is the meaning of it. Now here they are asking you to find the step response of the system. That means the output of the system is a step response. Now to get the step response, you have to apply an input that is a unit step function. So this you have to clear. So that's why the x of n is not given. They are just asking you in other way, find the step response of the system. So that's why the input of the system will be a unit step function. So that means our x of n is equal to u of n, and h of n is given, and here in between the system it will be convolved to get the output y of n. Okay. Let's plot the signals x of n and h of n. I am not going to plot. So why? I will explain that to you later. So first thing is how we are going to solve this. Now looking at the signals, you can see x of n is equal to u of n, that is a nothing but a unit step function. Now h of n is 3 by 4 to the power of n into u of n. So that means it's something like a decaying exponential signal. Okay, it looks like a decaying discrete time decaying exponential signal. Now I am not going to plot that exponential signal as n varies with respect to time here. So let's take this compared to x of n and h of n. H of n is little bit complex compared to x of n. Now I want to apply a different one approach. That means instead of going y of n is equal to x of n and h of n, x of n convolved with h of n, I will be using a commutative property which allows me to write h of n convolved with x of n. So in this case, that means I want to keep h of n as a constant one and x of n as a time shifted one. So that is the meaning of it. So if you expand this in equation form, so that will be equal to k is equal to minus infinity to plus infinity h of k x of n minus k. Now apply, observe here the values in the summation will be given to k here, but finally we want y of n, that is the time index y of n, the entire signal with the time index n here. Okay. Now just substitute the values of h of k and x of n minus k. So what is this? X of n is equal to u of n and h of n is equal to 3 by 4 to the power of n into u of n. Now I want h of k here. So that means you just replace n with k to get the term, just expressing in terms of k here. K is equal to minus infinity to plus infinity 3 by 4 to the power of k into u of k. So this is my h of k and x of n minus k. To get x of n minus k, see this x of n is equal to u of n, just replace n with n minus k. So you will get u of n minus k. So give a equation number for this for convenience. Okay. Now observe here, this u of k and u of n minus k, both of them are unit step function whose value will be equal to 1 for a certain duration. Now I will be taking these two simples. Now I want to get the limit from where to where these two u of k and u of n minus k for up to the which limit the value of u of k and u of n minus k will be 1. So that I want to clarify. So if that happens, I will find out for which values of k, u of k and u of n minus k will be 1, and I will be left only with 3 by 4 to the power of k to deal with. So that simplifies my process. Okay. Let's start with this. First, I will draw this u of k graphically. Okay. So you all know this u of n. So how you define u of n? U of n will be 1 for n greater than or equal to 0. So this is the from the definition with an amplitude 1. So it will take on this. Now if you want u of k, so the signal will be the same. Okay. So this is my u of k. So observe this, the time index here is, it is k. In the same way, let's plot u of n minus k. As I mentioned here, k represents the index. So u of n minus k is nothing but u of minus k plus n. So here n value we don't know. So that represents some time shifted value. So let's plot this. So to get u of minus k plus n, the steps we follow is, first we will plot u of k plus n and then we go for time reversal of this, that is u of minus k plus n. So these are the two steps. Okay. So let's take one by one. So first I will plot u of k plus n. Okay. So observe this, this is u of k, this is u of k varying from 0 to infinity with respect to k. Now here u of k plus n is there. So plus n means n will take the represents the time shift here, but the value of n is not specified. Since it is plus n, we have to shift towards left, but how many times we don't know. So that's why I will write a symbol here which represents the value of n. Since n value is not known, I'll just keep it as n it is. And how many times shifted we don't know. It may take any value, and the signal from here onwards 0 to infinity will be as it is. I'll keeping that u of k as it is. Okay. So don't forget the index here representing is k here. So this signal is u of k plus n. So next what we have to do, we have to take the time reversal version of this to get u of minus k plus n, which is nothing but u of n minus k. So let's do that. If you take the time reversal version of this, so this is u of minus k plus n, which is nothing but u of n minus k. Now this n is shifted to this side, and this the indexes will be taking the negative values because we are performing time reversal. So minus 1, minus 2, minus 3, minus 4, and it will go on. Okay, so this signal now is my u of n minus k. Okay, and for convenience, I am just writing u of k once again here. Why means I want to get the limit, so it will be easier if they are side by side or one below the other. So I am writing u of k. So u of k will be 1 for values of k which are greater than or equal to 0, and it is 0 for values of k which are less than 0. And I will re-mention the indexes 1, 2, 3, 4. I don't know where the value of n it is. N can take any value. Now observe this here in the expression 1, it is u of k multiplied with u of n minus k. So that means these two signals, u of n minus k and u of k, so they have to be multiplied. Now just observe, if you multiply these two signal here for values of k which are less than 0, u of k is 0, then if it is multiplied with 0, then you will get 0 only. So here and here, so this part will be 0. Okay. Now coming to the values of k which are greater than 0, we have some samples here, but these samples will be present only for till the value of n. Okay, so now whatever the value of n takes, from those samples only present, and the remaining will be 0. After n there is nothing, it is completely 0 here. So from 0 to n only the signal exists in u of n minus k. So if you multiply with that u of k, only the samples which come between 0 and n will be present, and that will be multiplied with that of the values of u of k. So if you take n value as 5, so that means from 0 to 5 the sample will exist in u of n minus k, and the samples from 0 to 5 only multiplied with the values of u of n minus k. Above 5, whatever the values u of k are, so that will become 0, because after this there is no signals, no samples left. Understood? So based on this, I will write the limit like this: u of k, u of n minus k. So these two, both of them has the same amplitude 1 and 1 here. 1 is the amplitude. So both of them, if since you are multiplying u of k and u of n minus k, so 1 into 1 will be 1 only. U of n minus k into u of k will be 1 for values of k, values of k greater than or equal to 0, but less than or equal to n. So this is what the first says. Second one, it will be 0 for values of k which are less than 0. So this is the first part expressing this u of k and u of n minus k. But consider the end product. What is the end product? That is y of n, and here n represents the time index. So we should also determine with the value of n as well. Now observe this, the value of n for is greater than or equal to 0, only the signal will be present, that is u of n minus k. Here for values of n which are less than 0, nothing is existing. So that means the signal will be 0 only. So that means you can represent like this: u of k, u of n minus k will be 1 for values of n which are greater than or equal to 0, and for values of n which are less than 0, it will be 0 only. So this is for with respect to index k, and this is for with respect to n, that is our final output signal. So we are representing that we have taken the limits here. Now we got the limit. Observe this: for values of k between 0 and n only, u of k, u of n minus k will be 1, and for values of k which are less than 0, u of k and u of n minus k will be 0. Now based on this, coming to the equation 1 here. So k is varying from minus infinity to plus infinity. So these two, u of k and u of n minus k. So what we got? So these two will be 1 for values of k which are greater than 0 but less than n. So that's why we take our limit will changes from k is equal to 0 to n, because only in that duration u of k and u of n minus k will be 1. So let's rewrite the equation 1 here. So therefore equation 1 becomes y of n is equal to summation k is equal to 0 to n 3 by 4 to the power of k into 1. Why I have written 1 means, because u of k and u of n minus k will be 1 for values of k greater than 0, less than or equal to n. So let's move on for this. So this can be simply written like this: k is equal to 0 to n 3 by 4 to the power of k. So just for simplicity. Now from geometric series we have a expression. It says summation n is equal to 0 to n a to the power of n is equal to a to the power of n plus 1 minus 1 divided by a minus 1, where a is not equal to 1. So this is a standard expression from geometric series. Now take this one and compare with this equation. So we have n is equal to 0 to n. So instead we have k is equal to 0 to small number, small letter n. In place of a we have 3 by 4, and this n and this n should be the same. We have same k and k. So comparing these two, we can apply this geometric series expression. Now using this, I am writing this expression: summation k is equal to 0 to n 3 by 4 to the power of k. So this becomes what? I am applying the series. So in place of a, I have 3 by 4. We have capital N, we have small n here. I am just writing the same term whatever we have. So here it may be n or it may be some integer value. Okay. So if we want some if n has an integer value, we just substitute that value and we simplify the same here. Okay. So n plus 1 minus 1 divided by 3 by 4 minus 1. So this is the final answer. That means y of n is equal to 3 by 4 to the power of n plus 1 minus 1 divided by 3 by 4 minus 1. Okay. So this is the final answer. Now in the problem, it is further extended. They have asked us to find, also evaluate the output of the system at n is equal to plus or minus 5. Now we have to apply the values for n here. Sorry, I have no. forgot write n here, y of n is equal to, okay. Now we have to apply the values for n here. For n is equal to 5, plus or minus 5 is given. First I will apply plus 5. So this above equation will become y of 5 is equal to 3 by 4 to the power of 5 plus 1 divided by 3 by 4 minus 1. Okay. So if you simplify this, you should get 3.28. So you will get 3.28 as an answer for value of n is equal to plus 5. Now for what about y of minus 5? So don't go like this, 3 by 4 minus 5 plus 1 minus 1 divided by 3 by 4 minus 1. If you perform operation like this, then it is completely wrong, because you come here, look at the limit for n less than 0, u of k and u of n minus k will be 0. Now if u of k, u of n minus k will be 0, so 0 multiplied with this term will be 0 only. So that means for values of n which are less than 0, our y of n will also be 0 only. So that means for y of minus 5, you can just simply write as 0. Why it is 0? Because u of k, u of n minus k is 0 for n less than 0. So this you can justify your answer. Okay. So if you go like this, if you apply the value for this and if you simplify, I think you don't get the, maybe you might get the same answer as well, 0 only. But you should not forget what happens to the equation of y of n. U of k, u of n minus k is equal to 0 for value of n less than 0. So that's why y of minus 5 will be 0. Okay. So this is the solution for the problem. Hope you have understood this. Anyhow, I will be sharing the same in the written copy for your reference. If you have any queries, please do reply. Thank you.